So the topic being discussed is importance of linear algebra in data science. Okay. So linear algebra is key to solving data science and machine learning problems. Linear algebra and statistics combined help create better data sets, leading to better analysis and insights of the data. What about data science? We all know data science is a multidisciplinary field, right? It combines statistics, machine learning, domain expertise, and that will help in getting insights from data. So, linear algebra becomes one of the fundamental building blocks of data science. So, whether it is data representation, algorithm implementation, efficiency, optimization, computations, interpretability, for all those aspects, linear algebra plays a huge role. Now, coming to data science, suddenly everybody is speaking about data science and data engineering and related buzzwords. Why now? Because we know that massive amounts of data being created in the form of internet data, in the form of social media, in the form of emails, in the form of online purchases, online banking, online medical, pharma, bioinformatics, social welfare, government, education, retail. All those aspects have become online, and they are generating huge data. And you have computing power, which is becoming more and more inexpensive, even in the form of clouds, where storage is possible, privacy and security is also maintained, right? So huge data is being generated. Now, once this data is generated, various products, say for example, you have Amazon. So we are all, rather I can say, addicted to Amazon purchases. Each one of us buys something on Amazon, and when we buy something on Amazon, we'll be checking out the recommendations. On Facebooks, we are recommended by friends. On OTTs, we get recommendations based on our choices. If we are dealing with stock market, we may get efficient trading algorithms and models to for better purchases. If we are going for a loan, then credit ratings plays a big role. If it is education, dynamic personalized education assessments in the form of like examples can be Khan Academy or Newton. If it is government policies based on data, so everything, all the new models, all the new products, whether it is recommendations, predictions, analysis, insights, all those aspects are derived from data. So that's why data science has suddenly become important. And there is a term called as datafication, coined by Kenneth Neil Cookier and Victor Meyer Schoenberger. What's the meaning of datafication? So it means that every activity, every task we perform is being datafied. For example, I go for a like on social media, that's datafied. So if I share my thoughts on Twitter, that's datafied. So if I grow my professional network in LinkedIn, that's datafied. I'm using Google augmented reality glasses, that will be datafying the gaze. So liking someone online, browsing the web, usage of cookies, walking around in a store, uh, everything is being datafied, sometimes intentionally via sensors, cameras, or Google glasses. So this datafication leads to better value for us, and for us as the modelers and the entrepreneurs who will be making money from getting people to buy stuff. Now there is always a confusion about the definition of data science, and always to cite or quote is this statisticians feeling bad that rather data science term is hijacked from us, because whatever data scientist does, we statisticians have been doing from since 100 years. But anyways, we know that data science is a multidisciplinary field. It combines statistics, it combines programming, it combines mathematics, it combines linear algebra, it combines Python programming, it combines visualization techniques. So all those aspects. So basically, it's multidisciplinary. And what exactly data science deals with. It deals with collecting the data, cleaning the data, processing the data, analyzing the data, identifying the trends, solving complex problem. So that's all it what is data science. As you can see here, all those are the core components of data science, be it data collection, cleaning, exploration, feature engineering. Applications of data science spread everywhere, be it healthcare or finance or marketing or e-commerce or manufacturing or environmental science or social science. Now, what is our focus actually? Our focus is to understand the importance of linear algebra in data science. So let us go back post this definition of data science and meaning of data application. Now, for any machine learning model, especially the deep neural networks and related evolved models, data representation direct textual is not possible. So it has to be converted into a numbers. So once it has to be converted into numbers, it has to be represented in the form of a matrix. And once it is represented, once the data is represented in the form of matrix, the matrix operations help facilitate many of processing and transformation easily possible, right? So that's why matrix and linear algebra and statistics play a huge role in data science as well in machine learning computations. For example, machine learning, the moment machine learning algorithm comes, the first core algorithm which can be mentioned is linear regression, right? So there is a dependent variable, there is an independent variable, and there is a relationship between those two. That linear relationship is there. It can be simple linear regression, or it can be multiple linear regression, or it can be logistic linear regression. So this is one of the model wherein your linear algebra can be used. Suppose you are performing dimensionality reduction. Now, the major techniques for dimensionality reduction are principal component analysis and single value decomposition. So, and what is the purpose of a dimensionality reductions? So, you'll be reducing your high dimensions into lower dimensions, is it not? But you'll be preserving the variance. You'll be through this you'll be improving the model efficiency and visualization. But for doing this, for dimensionality reduction for principal components, you need to make use of eigenvalues and eigenvectors. And what are eigenvalues and eigenvectors? They are again derived from matrix, and matrix is derived from linear algebra. So there is a dependency on linear algebra for principal components creation or dimensionality reduction. Even if you take deep learning models like neural networks, so it has forward propagation, backward propagation, weight updations. So they'll be totally dependent on matrix operations like multiplication, transposition, element-wise functions. So efficient computation of this matrix operation is crucial for training these large scale models. Even let us say you take a gradient descent. What is gradient descent? We all know gradient descent is an optimization algorithm. And what is the purpose of a gradient descent? It is used to minimize the loss function. And so how to derive that? To derive that, you will be using vector spaces, derivatives, matrix differentiation, and which are all linear algebra concepts only, right? So even if you take graph neural networks, there also dependency for adjacency matrices is there. Even eigenvalue decomposition and Laplacian matrices dependency is there, which are again derived from linear algebra. So take Python, you have NumPy, Pandas, TensorFlow, PyTorch. So they also are dependent on linear algebra operations. Even vectorization techniques, they are dependent on matrix operations. So in all, what we can say is data science is heavily dependent on linear algebra, and linear algebra is an indispensable pillar of data science. So with linear algebra, efficient data representation, transformation, model optimization is possible. Okay. So this was what we wanted to derive with this discussion. What was the discussion started with? The importance of linear algebra in data science, and we, with this small discussion, we could derive that data science is heavily dependent on linear algebra. Thank you.